All right, so let's hit question 1 here. It asks us to select the best statement. It gives us a series of choices, okay? So what this particular question is really getting at ultimately is the difference between chemical and physical properties and physical changes. And that's really, what this particular problem is essentially kind of all about. So there's these two domains, if you will, of science, right? There's physical properties, physical change, and then there's chemical properties and chemical change. And at the onset of your textbook, or on page 5 of your textbook, this says these are defined and discussed to a certain extent. We'd like the ability to understand what these key vocabulary words are all about if you're not sure, okay? So let's go over that real fast. So physical properties first are basically characteristics that a substance or a sample of matter will show by itself. It doesn't have to interact with anything. It doesn't have to change. It just demonstrate these properties by its very nature. So physical properties would be something like the color of the material, what color it exhibits, okay? Maybe it's melting point, or its boiling point. These are examples of physical properties. Whether or not it's an electrical conductor, a good conductor of heat. These are also examples of physical properties, okay? Now, on the other hand, chemical properties are a little bit different, because chemical properties are characteristics that the substance shows as it relates to its chemistry, all right? So chemical reactions are involved here. And what I mean by that is this sample of matter, does it have a tendency to react with another substance? Does it decompose under normal conditions of storage? And that's really what we're looking at when we're starting to talk about chemical properties, okay? So a chemical property would be an example of which is, whether or not that substance is flammable, whether or not that substance is an oxidizer, or whether it's a reducing agent, whether it's corrosive. All of these things are chemical properties, and the reason why is because it has to do with that sample of matter's ability to undergo chemical changes or chemical reactions, okay? So this is kind of, in a nutshell, what we mean between a physical property and chemical property, okay? They're not exactly the same, all right? Now, I know then that this problem involves chemical and physical changes. And we see that word a lot, all right? So what do we mean by chemical change then, okay? Because that's a little bit different than just a chemical property, isn't it? So what do we mean by chemical change? Well, a chemical change is basically a chemical reaction. And what chemical reactions more or less always involve is taking some substance, has to be at least one, sometimes we mix them together. We call those the reactants. That's what the starting material is, okay? Starting materials. Has to be at least one, can be more than that. We mix things together sometimes. But we take these starting materials, our reactants, and from them we create the products of the reaction. This is essentially what we make through the chemical reaction. So we take our reactants and we convert them into products. This is a chemical change, a chemical reaction. And of course, during our about many different types of chemical reactions, but this is essentially always what's going on. One or more substances is converted into a different substance with different composition, different properties, and this is what happens during a chemical change, right? So back to the question then. We're supposed to pick the best statement. And I'm looking here at choice A. Choice A says chemical changes always produce substances which are different from the starting materials. And I look at that one and I say, boy, that looks like a pretty good option to choose. But why are the other ones maybe not correct? So choice B is chemical changes are associated primarily with extensive properties. This is some more vocab, okay? Maybe you're not familiar with what we mean when we say extensive properties. So maybe we should take a minute or two to look at that and review that a little bit. Okay, what do we mean by extensive properties? All right, well, extensive properties is a property that depends on the amount of material present. And that's the key defining feature. It depends on the amount of the material present, the amount being the key word. So like the mass, for instance, is an example of extensive property. If you have more of a chemical, you have a higher mass. Volume, example of an extensive property. Volume is proportional to the amount of substance present. The bigger the volume, the more substance you have, okay? So this is what we mean by extensive property. Now, on the other hand, we have a different type of property that goes hand in hand in terms of vocabulary with this, and it's called intensive properties. Intensive properties. Intensive properties are different because an intensive property is a property of material or matter that will depend on the type of the matter present, like what it is, okay? It doesn't depend on the amount, but it depends on what it is, okay? So an intensive properties depends on the unique characteristics of what the substance is. Okay. So, like I said, the color of the material is an example of the intensive property or a physical property of the material. Okay. Its solubility in water is an example of an intensive property. Right? So, when we look back at choice B here, and it says chemical changes are associated primarily with the amount of material present, I'm not so sure about that. I mean, you could react a small amount of hydrogen gas and burn it in air. Or you could react a large amount of hydrogen gas and burn it in air, but the hydrogen gas will burn in air, whether it's a small amount or a large amount. Now, maybe that's a little boom or a small boom, because of course hydrogen's pretty flammable. And if you've ever seen a balloon of hydrogen explode and somebody light it on fire, right? You've seen that experiment firsthand. But you could have a small balloon of hydrogen or a large balloon. Both of them will burn in air. Okay? So chemical changes are not really associated with extensive properties in the amount of material. It's more innate. It's more intensive of a property. What about choice C? Chemical changes are accompanied by changes in the total mass of the substances involved. So what this is basically saying is that when we have a chemical change or a chemical reaction, the total mass of the substances involved changes. And that's actually not true at all. When you get into class, we'll talk more about the law of conservation of mass. And this is one of the first laws of chemistry, as it turns out. Whenever a chemical change or a chemical reaction occurs, the mass has to be conserved. You can't lose mass, you can't create it in a chemical reaction. So choice C is definitely not the case. What about choice D? Chemical changes are easily reversed by altering the temperature of the system. This is also generally not true. Once you run a reaction, changing the temperature may not easily reverse the reaction. Think about lighting a teaspoon of gasoline on fire. You'll combust it, you'll make water and carbon dioxide. Turns out combustion reactions generally make water and carbon dioxide as products. So we'll learn about that in chapter 4 down the road, predicting products of reactions. But you could take the products, the carbon dioxide and water, and maybe you cool them down, maybe you heat them up, but you really can't easily revert the products back to the fuel, the gasoline, can you? So you can't really easily reverse reactions by altering just the temperature of the system. That's usually not the case. In some chemical systems, maybe it is, but it's not necessarily common. And lastly, choice E says, chemical changes provide the only valid basis for identification of a substance. So can you identify a substance only by chemistry or chemical changes, their chemical reactions? That's actually not true at all. Chemists very often use physical properties to help provide clues what a chemical is. Things like boiling point or melting point, solubility of a material. All these physical properties or intensive properties can typically be used to help identify a material. So chemical change is not the only valid basis. So all these other choices, B, C, D, and E, they're not really true, which leaves us with our correct answer, which is A. Chemical changes always produce substances different from the starting materials, okay? So of course I ask you this question and you want to get it right to earn yourself some points here. But we're also considering some of these key vocabulary words along the way. That is chemical change and physical change, intensive properties and extensive properties. And we've dealt with all those working through this problem. And of course you have to know those things to get the answer correct, all right? So I want you to focus not only just getting the answer correct, which is important, I get that, I understand you want to earn the point, but also while you're at it and while you're working through chapter 1 here on your own, read over page 5 and make sure you understand physical properties, physical changes, chemical properties, chemical changes, and also intensive and extensive properties. These are all key vocabulary words. Get a good mental model of what all this is about before moving on.